Hello, everyone, and welcome to today's presentation. I'm Tammy Diedrich, the Managing Editor of IBM Systems Magazine, and I'm the moderator for this event. Today's webinar is sponsored by Optica Technologies and is titled Mainframe Virtual Tape for the Rest of Us. Our featured speakers today are Carl Burns and Gil Fisher. Carl is the Director of Product Management for Optica Technologies. He is a 25-year network and storage professional with 10 years of virtual tape experience in the enterprise arena. Gil is the Vice President of Engineering for Optica Technologies. He's responsible for Optica's development team and brings more than 30 years of experience in mainframe systems and technologies. Gil joined Optica in 1984, where he architects, designs, and manages the development of the company's many successful channel-attached technology solutions. Today, Carl and Gil will share how using virtual tape can improve storage efficiency and reduce manual tape processes in a way that's easy to deploy and easy on your budget. Following the presentation, we will have a brief Q&A period, so please feel free to enter your questions in the question panel on your screen anytime during the presentation. Now, without further ado, thanks again for joining us today. And Carl, I'll turn the presentation over to you.
Okay, thank you, Tammy, for the introduction, and thanks to the team at IBM Systems Magazine for hosting the presentation today. Also, for all those in attendance, we know your time is valuable and appreciate you joining us for this hour. I'd like to start with the agenda. So we're going to go through a brief history of Optica. Some of you may know us already. Gil's going to take us through that. What is virtual tape and why are customers deploying it? The idea here is that we're going to give you some background on virtual tape in general, and then an introduction of a specific zVT product that's Optica's. We're going to discuss some of the applications that are relevant for zVT and virtual tape, review some of the benefits that we talked about throughout the presentation, and then have a question and answer session at the end for everyone to ask questions of us. So without further ado, Gil, can you take us through the background?
Sure, thanks, Carl. Optica Technologies is first and foremost a solutions company. We've been around since the late 60s, always developing products that were not necessarily things that were widely accepted in the industry, allowing customers to do things like what we can do today is connect bus and tag peripherals to a brand new BC12 mainframe. I began working for Optica in 1983, and at that time we were the exclusive provider of plug-compatible peripherals for NCR mainframes. We were the first and only company to connect systems peripherals to NCR's bit serial link. Around the same time, in the early 80s, we began designing and building IBM channel matrix switch systems for bus and tag peripherals, so you could switch bus and tag peripherals amongst multiple mainframes. Our major competitors at that time were IBM T-Bar Data Switch. Many of those switches that we designed and built in the early 80s were still under maintenance as recently as 2 years ago. So again, we're a company that's been around for a long time, understand the mainframe business, and we support our customers till the very end. In the early 90s, we began making SCON to bus and tag converters, and we called this product FXBT, which stood for the converted channel, or CVC, to bus and tag conversion. The FXBT was a direct competitor to the IBM 9034, which you remember, I think they called it the muffler at the time. The FXBT and the 9034 both required a special converted mode SCON channel to operate correctly. In roughly 2001, through a close relationship with IBM, we became the sole provider of SCON to bus and tag conversion products. Today, we have sold roughly 24,000 of those converters. In addition to the FXBT, we developed a product to work behind channel extension so that you could extend bus and tag peripherals. But because it didn't work, because the extender companies did not support the CVC channel, we made a native SCON to bus and tag converter that was OEM'd by CNT, then by McData, and of course finally by Brocade. Working closely with IBM in 2003, we began designing a FICON to SCON converter that was later named Prism. Prism does not rely on a special channel protocol like the CVC channel. It takes native FICON and converts it to native SCON. This allows customers to simply connect their current SCON peripherals to the FICON channel without specifying a specific channel type. We also have the ability to take that conversion step one step further and allow you to connect a bus and tag device through the Prism and then back to the channel, allowing you to connect the bus and tag device to the FICON channel. Believe it or not, surprisingly, we still ship at least a few ESBT Prism combinations every month. So there are still people connecting bus and tag peripherals, and we're allowing them to do that. Developing channel conversion appliance is not for the faint of heart and requires a highly qualified set of skills. We built an engineering team over the last 40 years that literally you can't find the experience outside of IBM. We're a channel-exclusive channel company today. We have an extensive suite of IBM equipment, including the Z114 mainframe, multiple styles of DASD, printers, every kind of tape that you can find. We also have the ability to emulate and trace FICON, SCON, and even bus and tag channels and peripherals. This ability to emulate tape is what allowed us to build the zVT appliance that we're here to talk about today. Optica Technologies products have been installed in virtually every data center around the world. Our engineering technical support capabilities are unmatched in the industry. We have connected to virtually every peripheral ever made for the IBM channel attachment by every vendor that supplies them. We understand the mainframe environment and are fully committed to it now and for many years to come. Carl, with that, I'll pass it back to you.
Okay, thanks, Gil. So what we're here to talk about is virtual tape. And we've got a little description of, in general, what is a virtual tape appliance. The idea is we'll try to get everyone on the same page. I'm sure a lot of you have already heard of virtual tape, and this may be a review. But the idea is that this device will emulate a tape drive. So to the host, to the mainframe, over the channel connection, whether it's FICON or SCON, the device looks like a real tape drive. And with that, the functionality of tape drives comes with it. So all the applications that you use with tape are available to use with the virtual tape. And the host just thinks it's writing to a physical tape drive. And there are backup applications and HSM and those types of utility. There are generally two types of virtual tape systems. The disk as cache, and that's where this started, where the idea is to optimize tape on the background, but you're still using physical tape. So you might be writing to the disk cache for performance reasons to be able to get the data off of the host more quickly, and you might be writing to physical tape and possibly stacking the backups or the data sets onto physical tapes to better utilize the capacity of these physical tapes. And with that comes along those limitations of physical tape, whether it's the capacity of the tape or the fact that you have to manage this piece of plastic. The next to come along was using disk as storage. So you may or may not use physical tape in this environment. And it's up to you which data sets you might need for physical tape if you're possibly going to transfer them to another location or maybe to a different vendor. You put a small data set on physical tape. And there's certainly good uses for physical tape today. But most of the data is going to reside on the disk cache. And in this way, the disk cache is typically larger, and you're using modern disk array subsystems. And with these modern disk arrays, you get a lot of benefits such as replication, compression, deduplication, and encryption. And the functionality of this allows you to communicate between a primary production location, a disaster recovery for replication. You can choose to encrypt certain types of data and to be able to better utilize the disk space and spend less on the disk. You have compression and deduplication. So why are people using the virtual tape solution? What is driving them to make that change? Because it takes time and effort to move away from physical tape. You already have all these processes in place in the mainframe arena usually for a lot of years. And what we're finding is that people are using it to improve their tape-based process performance. So they're writing backups quicker. They're restoring data sets much, much quicker because it takes very little time to access that data. You don't have the errors with physical tape. But with a physical tape, you can have dropouts on the media. You could lose a piece of media. But when you're writing to a disk array, it's a redundant set of disks. If one disk does fail, you have RAID that's controlling it and automatically rebuilds onto a spare disk, and so you don't see those issues. In addition, the physical tape drives are large, and they're expensive to maintain. You often have an operator that might be full-time doing that, where you could reduce that, have the operator doing part-time on tape operations and part-time doing some other things. As I mentioned a little bit earlier, some of the functionality about the encryption and the replication and vaulting gives you this security, so you don't have any issues with tapes being lost, they fall off the truck, etc., in the process of sending them to the vault, because data is transmitted over a secure link to the remote location, and with that, you don't have any physical transfer of the media. So I've talked about what we've seen in the past, and I have a question for you. Do you have a virtual tape project identified in the coming years, this year, next year, or later? And that's one of our first poll questions. While you're thinking about that, we have a poll that was actually done by the ESG research group. And these are customers that actually implemented a virtual tape system, and they talked about what it is, the benefits that they got from doing this. And the first reason was to improve recovery performance. So the idea that you're getting the data off of the virtual cartridge so quickly because you can mount it and seek to it very quickly, then that gives you this benefit of virtual tape right off as soon as you install the product. Some of these others were important to people. Improving backup performance is one of them, reducing tape management issues, etc. But what we found is that these customers are primarily doing it for performance and for the management issues. It looks like we have a response from our poll, and it's fairly evenly weighted, about 1/3 for each of the categories. It's very interesting. So there is an interest in virtual tape. Obviously, we have a group of people on our webinar today that are interested in virtual tape. Otherwise, you probably wouldn't have attended. And that's very good to hear. So let's talk about the zVT. That's basically why we're here. zVT is the name we gave to our virtual tape appliance, and builds team developed this and architected the product. The specifications are based on an IBM server. So we're looking at a standard IBM server, and this is the same one that we use for our Prism product. We're very familiar with the hardware, and we are using very similar process in the development. The base, the core of it is very similar to the Prism because we are still using these SCON and PHYCON protocols. That underlying structure still remains. So we're using the protocols, and we're emulating 3490, 3590 tape devices. And with that, the load display messages that are sent, requests to load a cartridge, they get intercepted by the virtual tape appliance, and that virtual cartridge will get mounted and become ready immediately. And the idea here is that there's no operator necessary, and it happens programmatically as soon as it's requested. In addition, if you request a scratch tape, we've got the provision there to have scratch pools, and tapes will get mounted as scratch. So you have that availability also. We license the product per virtual tape drive. So you can have a number of connections, 16, 32, etc. But you can write as much data as you want. There's no limitations to that. It's as much disk space as you want to put on the zVT. You can have that much data written. And this gives customers a lot of flexibility because they might want to save data sets for longer, and they might have production environments and development environments that they would prefer to keep data backed up on. For the input and output, we have either PHYCON interface or SCON interfaces. So depending on where you are in the environment where your system is, your IBM mainframe, you have a choice of doing that. And if later on you want to convert, you have purchase an SCON, we can change it over to PHYCON later. It's not set in stone. And then for storage connectivity, we basically have anything available. If you want to go with network attached storage, NAS, then the NFS connectivity, pretty much any storage device is fine. When we talk about Fiber Channel or iSCSI, then we'll want to talk to you about that specifically. But most devices, it's very standard protocols, and will support most devices. And with that storage, as I mentioned earlier, it comes along with often replication, deduplication, compression, encryption. You're getting all that function and feature set right out of the disk storage, and so we're allowing you to reap those benefits of the modern storage devices. For the interface itself, and managing the device, we have several different methods. We're going to go through those in a minute. The web-based graphical user interface is the first step, and it's very easy to install. We've got policy-based management, and the idea here is that you set a group of policies for the virtual tape cartridges and group them together, essentially. So the cartridges have similar properties. Tape volumes can have a virtually unlimited size, although you can set a limit. But the idea here is that there are some processes that you might want to use a larger cartridge, but you don't know how big it's going to grow, so you can set the limit very high. For configuration and support, we generally have a relationship with a reseller, and we're working with them to gather information about your environment and recommend the proper design for the zVT. And then for support, it is in-house Optica support on all the code, and then we have IBM hardware support. So the same technician that might be working on your mainframe would come in and work on this device as well. So we have that globally, anywhere in the world that IBM has their support team will have feet on the ground. So in this slide, we talk about the policy management. And this is one of the first pages that you're probably going to set up. There are a couple other pages that you can go to define the virtual tape drives and the communication to the mainframe. Then we have our storage, where you define where the storage goes, that's the disk array, and attaching that storage to zVT. And this policy management page. And you can see here that, let me get my pointer back. That we have drop-down boxes and fill-in boxes for you to be able to create the virtual cartridges and set the policies for them. And here we have the volume serial number. Very simply, you put in the first volume that you want to define, and then a range. And the range would be 15. If you start with 1 and the range is 15, then you get 15 cartridges. The path is the storage location. And you might want to choose different storage locations for different purposes. You might have different data sets that you want to keep on high-capacity disk or fast disk, or one of the disk arrays has deduplication, so you use that for the backups, but the other one has compression, so you use that for HSM because you probably won't get any deduplication out of HSM data. HSM is one version of the data set. We have the type, and this is whether it's going to be a data cartridge or a scratch cartridge, or there's a third type of cartridge, and this is our zVT command cartridge. So what we've done is in band on the SCON and FICON channels, we're going to be able to receive messages from the mainframe and send messages back to the mainframe. So there aren't any outside communication channels that you need to configure. All this communication is going to go over the primary channels. And we use a virtual cartridge to set that data. And you write the data to this virtual cartridge. It's read on the mainframe. The mainframe can manipulate that data, maybe write data back to this virtual cartridge, and then the zVT can interpret that. So this gives us a lot of flexibility in communicating and managing the zVT directly from the mainframe. And once you set up your environment on the zVT, you can do so much just from the mainframe and with tools that you're familiar with, JCL, et cetera. The label type, fairly simple, standard labels, ANSI labels, no labels, and then the maximum size. And you can put a value in here. Maybe you want it to be 4 gigabytes or 1 terabyte, and that's the drop-down list to the right. And once you do this, you click on the Add Next, and it creates the virtual cartridges. And you can see here, we've created several groups of those virtual cartridges, and they have different properties. And you're able to manage these through the group, or individually, actually. If we had a live unit up, I could click on one of the list tabs here and show the list of the cartridges and drill down to each individual one. In addition to the graphical interface, we also have a command line interface. And this is, obviously you can see it here, this is Linux. So we've got this Linux platform, and all of the commands that you can do from the graphical interface, you can also do from the command line. And this gives us that next step to that powerful tool of doing the commands from the mainframe. And this example just lists out some of the commands that you can use. This is the help command. And in the lower box, we've done help on a specific command, which is the create command. And it gives you the syntax for the options for this command. So with that understanding that all these commands are available on this command line interface, what we can do is communicate via JCL, and some of these commands get passed back and forth. And maybe Gil can speak a little bit more about this.
Yes, thanks, Carl. So what we've done is we've created a what we call zVT command, although it's not really, it's basically just a way to, from the host, send commands that you would like to affect on the zVT appliance. The zVT appliance, as Carl said earlier, it runs on a Linux operating system, and every command that you can do in Linux, you can also do from the host on the zVT appliance. And the way that's done is, as Carl described earlier, we use a policy-based management of the system. So if you create a volume, a Valser range of cartridges, of virtual cartridges, you can say, I want these cartridges to go to this subsystem, or I want to go to this system that gets replicated or has dedupe or whatever. Different virtual libraries, I guess, would be a good example. One of the parameters that you can also set is whether this is a data tape or a scratch tape. Obviously, it's a data tape, then you're going to mount that tape, you're going to write to it by its Valser. If it's a scratch tape, either using scratch synonyms or private or scratch, it'll release that tape from the scratch pool, allow you to use it, and then that tape will become a data tape. The third parameter you can put on a Valser is you can call it a zVT command volume. If it's a zVT command volume, then the zVT, whenever that volume is mounted, the zVT recognizes that, and then instead of letting you read and write that tape like a normal tape, the data that you write to that tape will get processed, and those commands will be executed on the zVT. So you put the commands in the data set. So if you look at this top one there, you'll see zVT-in, which is just a data set that has two lines in it. And the first line is CMD, open parenthesis, list, and then right parenthesis. When the zVT reads that line, it will execute that command. And the list command lists the policies that are currently in the zVT, all of them. You could list partials, you could list different filters on your list, but in this case, we're just listing all of them. The second one says execute this Linux command called df, which basically just tells you about your disk system in Linux. And then that data set that you wrote to the zVT, if you turn around and remount that tape and read the data set back, the results from those commands will be in the data set that you originally wrote. So you'll see there results for command list, and then that's the results. Valser command 000, range of 2, the path to where it was at, and the policies that were set for that tape. Then you see the results for command df, and you see the rest of those lines come directly from Linux. File system 1K blocks used available. So that's information directly from Linux. So it's a very, very simple way to affect any command that you would like to do on the zVT and get results back in a data set back to you. So that's basically how we, and anything you can do on the zVT can be done through that same interface. With that, Carl, back to you.
Okay, thanks, Gil. So you've seen the three methods that we have to interface with the zVT, and now let's go through some of the applications that you would use a zVT for. Give a little background. We already talked a little bit about this, but looks like a standard tape drive, and because of that, being transparent to the host, all of those applications that you normally use tape drives, you use for virtual tape drives. One of the primary reasons is to optimize backups, and especially recovery. And the benefits here of virtual tape are that the tapes are mounted and online immediately. You don't have to wait for an operator to insert tape. You don't have to wait for the tape to wind up and find a location. And what's very interesting is because you've got spinning disk and you have pointers to the disk where the data is located, you don't have to wait for tape media to actually move on reels and for the head to find the data on the tape. It goes nearly instantly to the location on the disk and starts to read back your data set. So you've got that benefit, as well as virtual cartridges just use the amount of disk space that you've written the data, and possibly even less if you're using compression or duplication. So you don't have this stack of partially used tapes where you're writing these small data sets to a tape that has a much larger capacity. One of the great benefits of virtual tape is that you can define a whole bunch of them. It's really easy. You just configure it in zVT and configure it on the mainframe, and within a few minutes, you have more virtual tape drives that you can use. With physical tape drives, you'd have to order hardware and get it shipped in and mounted and cabled and power and everything like that. But if you needed to have a new project and you have more need for virtual cartridges and virtual tape, then you might just license more virtual drives, or you might have the license already and just assign some of them. So you don't have all this floor space, power requirements, and cooling requirements for these big mainframe tape drives. In addition, you don't have really any worries about the media life. The disk arrays are redundant and self-healing, and if there are any issues, they just take care of it by rebuilding onto extra disks. HSM was an interesting idea for virtual tape because typically you're writing data off to a slower storage. That's the hierarchy of hierarchical storage. You've got this very expensive storage on the mainframe, and you have a data set that's not required to be directly on that disk that's within the mainframe. So you want to move it off, but you still want to have access to it. Traditionally, this was done with tape, and if you wanted to retrieve that data, you would send a mount request for the tape and mount the tape. If you had a robotic library, that might happen programmatically, and a robot goes and picks the tape and loads it. It could be up and ready in a minute. With a virtual cartridge, that's a second. You just request the virtual cartridge gets mounted, and the data is now ready for you to retrieve. So you've got the added benefit with HSM where the hierarchy is a little bit closer than it used to be. The distance between the performance of the internal disk on the mainframe and a physical tape drive is a much bigger difference than the difference between internal disk on the mainframe and the disk array of the virtual tape. And there's some similar benefits here as well, as the backup and restore, instant seek times, etc. Virtual tape also gives you a lot of flexibility with disaster recovery. You could have the data set on your virtual cartridge and in a disk array locally at your production site, and replicate that to a disaster recovery site, or it could be replicated to another corporate location. And that's a one-to-one relationship, but you can do other things too. You could have it go to two locations to the DR site and to another corporate location, because maybe the corporate location is just down the street, but the DR site is has a different power grid, and it's a different, hundreds of miles away. So you've got this flexibility in doing the replication process. And at this point, we have one more poll question. As far as features that you would use with virtual tape, which are you interested in? And we talked about some of the reasons for using deduplication. Its benefits are usually for backup, where you're repeating the data set over and over because you back it up on Monday and Tuesday and Wednesday and Thursday. And that data set changes slightly, but much of the data set might remain the same. Compression might be better for the hierarchical storage because it's a single version of that data set. Replication is kind of on its own, where you're copying data to another location, and this is a replacement essentially for shipping physical tapes. And encryption, this is becoming more and more important when we find about data centers being hacked. So looks like we have the poll results, and most people are saying replication's the most important. Compression is not quite as valuable as deduplication, and encryption is important for about a quarter of it. So this is what we're typically seeing in the environments, and it's good to see that our attendance here is a good sample of that. So thank you very much. Our next to last slides here is just a review of some of the topics that we already talked about. And you can read some of these as a reminder, but the last two here are the ones that I wanted to touch on. The Optica zVT is based on an IBM server and the same platform as our Prism product that Gil talked about, that has been out in the field and in so many data centers, and very reliable, supported by Optica, our in-house team. It's not outsourced anywhere. And as far as hardware, if a power supply fails or something like that in the field, then IBM is dispatched very quickly to be able to replace that. And the last item we haven't talked about at all is that we've set the zVT to be reasonably priced, and we designed it specifically for the mainframe user who's business class user or smaller enterprise class user doesn't need all those powerful tools and utilities that maybe the IBM virtual tape has. And because of that, it's easy to implement. We have installations I've personally been on, and within a couple of hours, we've mounted the unit in the rack, we've configured it, we've defined the storage, we have communication to the mainframe, and now we're starting to just define the processes that are going to write to it. So in the same day, we were actually writing data to the zVT. The last two slides we have here are some design examples, and Gil and I are going to talk a little bit about these. The idea is to have something visual for you to see when we're talking about what the possibilities are with implementing the zVT in your environment. So, Gil, do you want to talk about the first one here?
Sure. I mean, basically, we're just showing that if you have 3590 or 3490 on SCON channels, you can, if you have SCON channels, you can just drop a zVT in, connect up to your SCON channels, and emulate those same devices with storage. You can also upgrade to FICON. If you got a new mainframe, then more than likely you would want to use FICON to upgrade to virtual tape and replace those drives. We support both. so that's basically it on that one.
And on this second slide, it's slightly different. The idea here is that you might already have a prism converter in your environment.
Right. So, hey, there's a poll question there, Carl. Might want to get the...
Oh, yes, thank you. So the last poll, one last question for you guys. With a virtual tape system in your environment, do you think you would continue to need physical tape installed? And we have a little bit of that here, where you've got new mainframe, got a prism, and you have an SCON connected tape drive, but you also have zVT and your virtual tape environment. So we think that there's a need for physical tape still. You might be writing tapes that go off to a client that still uses physical tape, and that's the way that you have been transferring data to them. You might have some regulatory requirements that the auditors require physical tape off-site in a vault, or long-term storage. You have to keep this data forever. It's a healthcare organization, and you need it. Okay, so our poll results are back, and it looks like about 2/3 say yes, physical tape is going to be required in their environment. That's good to hear, because that was our expectation as well. And with the zVT, we have this flexibility to incorporate Prism and design multiple scenarios where you could have a legacy mainframe with SCON connections, or you could have a modern mainframe with ICON connections and put a Prism in, still keep your SCON tape drives. There are a number of design philosophies. We could also have ICON connection to the zVT directly, but still have the Prism just doing the connection to the SCON legacy tape drives. Is there anything you'd like to add here, Gil?
Yeah, just one of the questions that came in. I just real quick, I'll address he was asking if zVT had, direct path to tape. Part of the question, that poll question, was I was more interested in understanding whether people still needed the 34s and 3590s. I mean, do we need those legacy tape connectivity, and would it be valuable for the zVT to directly communicate to them? We obviously have the technology to do that. We do that every day in our lab. We can emulate channels, and we can emulate control units. So the technology is not beyond us. The question is, does the product need to have tape attached directly to the product? That would allow us, for example, to read a 3590 tape right off of the SCON channel and copy it into zVT, or furthermore, take a Valser that's in zVT and write it out to a 3590 tape drive without host intervention. Those would be things that we certainly have the technology to do. It's really a matter of how many customers need that connectivity. It sounds like people obviously still need legacy tape drives, but do we just need tape, or do we need to actually communicate to the 35s and 3490s that we currently have in our environment?
Okay. Well, speaking of questions, we're at this point where we're going to open up for a Q&A session, and we'll have some other Optica team members replying to some of these messages as well.
All right, great. So we will take a few minutes to answer some questions now. Again, if you have a question, you can use the Q&A panel on the right side of your screen to send it in. Okay, first question. What disk storage can I connect to zVT?
Okay, well, I'll take that one. This is Carl, and so zVT is compatible with most storage devices. What we have for the NAS connectivity network attached is NFS, and that's a very standard protocol, and any storage device that supports NFS will be compatible. With the iSCSI and fiber channel devices, the protocols are very standard, and that's not the issue. It's just sometimes that there are multiple paths and path failover, things like that, that we want to talk to you about the specifics, how you want to design that, because some of those devices require drivers specific on the host side, which would be the zVT. But in general, we're open to all devices on that those two channels as well. Okay.
Okay. Is replication handled by zVT or is it by the storage system?
I'll take that one, Carl. That's handled by the storage system. We don't have today replication of the product. That's handled. We assume that will be handled by the back-end storage.
Okay. Will this appliance support VSE, ZVM, Linux on Z via FCP, and ZTPF environments as well as ZOS?
Definitely ZOS, ZVSE, and ZVM. Yes. Z for Linux, not out of the box, out of the gate, and same with TPF, not out of the gate.
Right. Does replication require the remote processor to be active or just the zVT device?
Again, that's handled in the storage subsystem, so it would be the storage system be replicating that the remote host would not have to be active.
Right. We are a VM VSE shop running CA Dynam/T for backups. Do you support that environment?
We will. We don't have direct support for it today, but we will have that.
All right. How do you deliver dedupe? Rely on the back-end storage? Whose storage?
Same answer. We do rely on the storage, and we don't have a limitation on what storage you can connect to the back of our product. So an NFS device that's dedupe capable, the Protect Tier products from IBM, the HydroStore from NEC, anybody's product that supports dedupe, we're virtualizing the cartridge and write them to that storage. So it's done by the storage.
All right. Does it interface with ZVS, Epic, and Dynamic T TMSs?
Yeah, the tape management systems. We intend to support the major tape management systems.
All right, great. Is there a limit on storage capacity and virtual volumes?
There is not. That limit is storage based on the storage you have connected. We have no limit. As Carl said earlier, we support 16 to 256 virtual tape drives per zVT appliance. So you could be writing, 64 simultaneous tape drives running at the same time to multiple different storages off the back end of the product. We do not limit capacity.
Okay. Is there any internal storage or only external storage?
Obviously, we have internal storage, and it's the same as fiber channel storage. I mean, whatever storage is available, we can access it. We don't have a clear roadmap on whether we're going to have internal storage inside the product or not.
All right. How do I find out how to configure zVT?
Okay, I'll take that, Carl. So we have more information on our website. There is a data sheet, and we would work with our partners in collecting information. But in general, the ability to configure it is very straightforward. We have documentation that describes the installation, the physical hardware installation, and then the configuration of all the parameters, and it's something that the end user can do. And it would, just take half a day maybe for you to do.
All right, so that kind of goes right into my next question, which is, can I implement zVT myself, and can I manage changes on the zVT configuration myself?
Okay, I'll take that as well.
Absolutely. Oh, go ahead.
Absolutely.
Sorry, Carl.
Yes. Yes, definitely. You can implement it yourself. We are happy to assist in the design process. We have obviously experience with the product and the environment, so we'd like to be able to help to define that and guide you. And once it's configured, all of that management you can do on your own through those three interfaces: the graphical interface, the command line, and the JCL interface.
All right, and can IBM provide the maintenance and support for zVT?
So this is Sean Seitz with Optica, and I'm happy to take that question. So exactly like our Prism FICON to SCON converter solution, we partner with IBM globally to as part of our maintenance model. So for all Optica products, the first call is always to Optica, and we have a subcontracted arrangement with IBM through an international TSA that allows us to dispatch IBM SSRs to serve as our hands and feet. So essentially, it's a partnership with IBM. So in most countries, if you have an SSR who normally would respond to support the mainframe on site for you, it would be the same exact resource, same exact SSR who would respond if there were a hardware action required or an on-site maintenance-related action required in support of zVT. It would be the same resource that we would dispatch to help you. So it's a well established model that we've had for going on 12 or 13 years now with IBM. So I think it's a comfortable model for every mainframe customer.
All right, I have a question here about the max single stream write speed to one virtual tape drive in megabits per second. Do you know what the maximum single stream write speed is?
That would depend on the storage, but we support multiple paths into one tape drive for sure, and but that would depend on the storage. If you've got it hooked up on a 1 gigabit Ethernet link to an NFS, it's obviously going to be a lot slower than if it's directly attached on the fiber channel link. And it depends on whether you have FICON or SCON. We've measured 18 megabytes on SCON. We haven't measured FICON yet.
Right. Can you emulate 3490 and 3590 tape drives on one zVT?
Yes.
All right, great. Well, looking at the time, I want to be appreciative of the audience's time, so I'm going to wrap it up right now. Thank you, Carl and Gil, for sharing your expertise with us today. Just a quick note that we will be sending out a link early next week to a recording of today's presentation to everyone who's on the call, as well as to anyone who registered for the event but whatever reason couldn't make it. So that concludes our webinar. Thanks for joining us today, and have a great day.